Why is MIT making robot insects? In recent years, the Massachusetts Institute of Technology (MIT) has been at the forefront of robotics innovation, particularly in the development of miniature robotic insects. These tiny insect-inspired robots, often no larger than a coin, represent a fascinating convergence of biology, engineering, and technology. But why is MIT investing time and resources into creating robot insects? The answer lies in the potential applications of these devices, which range from environmental monitoring to search and rescue missions, and even medical advancements. By mimicking the form and function of insects, MIT researchers are unlocking new possibilities for robotics that could revolutionize various fields. The inspiration behind robot insects? Insects are among nature's most efficient and adaptable creatures. They can fly, crawl, and navigate complex environments with ease, making them ideal models for robotics. MIT's researchers have drawn inspiration from the biomechanics of insects to design robots that replicate their agility and resilience. For example, the Robobi, one of MIT's most famous creations, is a tiny robotic bee capable of hovering and flying just like its biological counterpart. By studying the flight mechanisms of bees, researchers have been able to create robots that can perform delicate maneuvers in tight spaces, a feat that traditional drones struggle to achieve. Applications in environmental monitoring. One of the primary reasons MIT is developing robot insects is their potential for environmental monitoring. These robots can be deployed in large numbers to collect data on air quality, temperature, humidity, and other environmental factors. Their small size allows them to access areas that are difficult or dangerous for humans to reach, such as dense forests, disaster zones, or even the interiors of industrial facilities. Equipped with sensors, robot insects can provide real-time data that helps scientists and policymakers make informed decisions about environmental conservation and disaster response. Search and rescue missions. Another critical application of robot insects is in search and rescue operations. In the aftermath of natural disasters, such as earthquakes or building collapses, time is of the essence. Traditional search and rescue teams often face challenges in locating survivors trapped under rubble. Robot insects, with their ability to navigate tight spaces and fly over obstacles, can be deployed to search for survivors more efficiently. Their small size and agility enable them to access areas that larger robots or humans cannot, potentially saving lives in the process. Medical advancements. MIT's robot insects also hold promise in the field of medicine. Researchers are exploring the use of these tiny robots for minimally invasive surgeries and targeted drug delivery. For instance, a robotic insect could be designed to navigate the human body, delivering medication directly to a tumor or performing delicate surgical procedures with precision. This could reduce the risks associated with traditional surgeries and improve patient outcomes. Additionally, robot insects could be used to monitor patients' vital signs from within the body, providing continuous real-time data to healthcare providers, challenges, and future directions. Despite their potential, robot insects face several challenges. One of the biggest hurdles is power supply. Current models often rely on external power sources or have limited battery life, which restricts their operational time. MIT researchers are actively working on solutions, such as wireless charging and energy-efficient designs, to overcome this limitation. Another challenge is scalability. Producing these robots on a large scale while maintaining their precision and functionality requires advancements in manufacturing techniques. Looking ahead, the future of robot insects is bright. As technology continues to evolve, these tiny robots could become even more sophisticated, with enhanced capabilities and broader applications. MIT's work in this field is not just about creating robots. It's about pushing the boundaries of what is possible in robotics and inspiring new innovations that could benefit society in countless ways.